Hey everyone, and welcome to a new video on this channel. In this one, we'll investigate a fast path to create and use LLM flows in your own custom Python applications. And what we'll use is Microsoft's prompt flow. Now, why would you want to use prompt flow in this case? Well, it allows you to visually design flows. You don't have to dive into YAML and a lot of Python code for everything you do. And you still can, in a flow, use custom Python tools together with pre-made tools, LLMs and prompts, and you build them, you string them together in a flow to get from an input to a desired output. Another advantage that this environment has is that you can also use prompt flow to evaluate your flows, to get some kind of metric out to see how well your flows are doing. Then you can think of optimizing the flows, for example, to consume less tokens or to get better results. And lastly, you can also deploy them in multiple ways. You can deploy them to an online endpoint in Azure, you can deploy them using containers, but we are going to deploy it using embedding within a Python application. And you'll see how easy it is to do that. Now, what's a flow exactly? A flow is simply a directed acyclical graph, a DAG of functions. We also call them tools. And these different tools, they have input and output dependencies. So the output of one tool will be sent to the input of another tool. And that's how you visually build such a graph. So in this case, you see an input. The input is going to an embedding node. We then use that embedding in a search. Then we use that search result in an LLM call, and we finally get an output. And we'll build something similar to what you see here in the rest of this video. Now, you can build these kind of flows using the Azure portal. Here you see an example, and there are basically three types of flows: a standard flow, a chat flow, and then an evaluation flow, which is used to evaluate other flows. And there are many examples as well that you can start from the portal. In this video, however, we are going to focus on using prompt flow within Visual Studio Code, which is also a great option if you prefer working that way. And it has some extra interesting features, such as easily embedding this flow inside your own applications. So we will use Visual Studio Code in this case. So let's get started with getting everything ready and seeing a bit what we're going to build. What we want to build here is an application that can search for images. I simply enter a query or a description, like for example, I like a fierce feline hunter, and if I press enter here, what I get is a result. The first thing that happens is we do a search in a vector store that gives me several images, and then we do a second LLM pass. Basically, we ask a GPT model, look, what would be the best picture that matches here? In this case, fierce feline hunter, well, a tiger matches better than that cute cat we see as the second alternative picture. So to be well understood here, this is a picture that was selected by the LLM to match best with the query. The actual result to our vector database resulted in those two images. And I can see that here, the first result from the vector database was just the cat picture, right, with this URL. Just the second entry was the tiger picture, but the LLM chose the tiger picture anyway as a better match to this description. So what we're going to do is we're going to build this using prompt flow. So here you see the prompt flow that's going to be used, and I'll make this a little bit bigger that you can see it visually. We're going to take a look at how we build this flow in a moment, but the input, that's of course my query here, like fierce feline hunter or creature, and then the actual output will be the URL, but also the image representation in base64 encoding. To build this flow, you need a couple of things. First of all, of course, Visual Studio Code, and you need also a extension installed, that is the prompt flow extension. And this prompt flow extension will also install a couple of Python packages like the prompt flow package and the prompt flow tools package. And you find information on Microsoft Learn to do this properly. Now, to get started, you typically start with an empty flow. I'm not going to start from that starting experience. I'm going to show you how this is all built up into several different pieces. Now, what you always will start with is this kind of input node, right? So all these things are called nodes, and these nodes, they are built together into a DAG, a directed acyclical graph, that eventually will lead to an output. So in my case, as you have seen in the application that I've shown before, the input is a description, like for example, fierce feline hunter that you see here as a value. And then the output in my case is going to be the base64 encoding of the image, and then the URL to the image. We can use that, for example, to grab the image from its original location. But in between, of course, we want to go from that input to the output. And the first thing I'm doing is I will need an embedding. I will need to have a vector representation of the description that I put here. So there's an embedding tool you can use straight away. You can see that here in this plus option here. There you can add tools, and one of the tools is going to be an embedding tool coming from the PromptFlow tools package. So when I insert that embedding tool, you get this. Now, what does this embedding tool need? It needs a connection to a embedding model. And in this case, we use an Azure OpenAI connection. The connections can be defined in the PromptFlow extension from the connections list here. So when I open the connections, it takes a while to open them up. And here I have my Azure OpenAI connections. To create a new connection, you would simply click plus and you would enter all the values that you need, but you would never type in the API key. That's something you will be asked to type after you click create connection. These connections, in my case, they are stored into a local SQLite database. That's all managed by PromptFlow for you. So when we have this embedding tool added and I have my OpenAI connection, I also need a model that will do the actual embedding for me. So I'm using an OpenAI resource in Azure. So my Azure OpenAI resource has a model deployed and I called it embedding. And that's the text embedding ADA 002 model, which is the well-known embedding model from OpenAI. And what am I going to embed? The description I typed in the input. So you can simply here select from a list of outputs from other nodes, but I want from the input node, I want the description. So that means that if I enter the input here and I were to click on play here to start the flow, this embedding would create that vector from my input. And I can show you already what that does. If I go to the embedding tool here, I can show you from a previous run what happens here. So here you see indeed the output and the logs, that the input was the description that I put in. The input was fierce feline hunter. The output was a list of floating point numbers. That's our vector that was created. It's Azure OpenAI with 1536 floating point numbers in an array. So that's how the first part of this flow works. Before we continue with the other nodes, you should be aware that this is the visual representation of our flow. Normally, when you create a new flow within Visual Studio Code, for example, you can do something like this here. You can say right-click and then new flow in this directory. What you will get is a flow.dag.yaml file. And this flow.dag.yaml file by default will be a YAML file with everything in it that defines the flow. If you really wanted to, you could work here within this YAML file, but as you can see, we have some options at the top, several options there. One of them is the visual editor option. So I'm going to continue working in that visual editor option because that is going to be the best thing or the easiest thing to do in a video like this. So let's move on to the other nodes, and sometimes you'll see me trying to get this stuff properly on the screen. So that's normal. It's a little bit of working with screen real estate here because I'm trying to zoom in a bit on this system. But anyway, the second thing we're going to do here is now to do a search in a vector database. This search, I could write some Python code for this, but there's also a tool to do so. So here, when I click on plus, there is this tool which is called the Vector DB Lookup tool. Now I must tell you that this tool is going to be deprecated. It still works today. It will be replaced by something else, but I'm still going to use that tool. Now, of course, you need to know a little bit about Azure AI Search and what vector search is. I suppose that you already know a couple of things about that. So in my case, first we'll need to have a connection to my vector database. Again, that is a connection similar to a connection to an Azure OpenAI resource. So in my connections list, you see that there is a connection that is going to cognitive search. That's the old name for AI search. And that connection is called ACS GEBA. Yeah? Of course, within that connection, there is an API key as well and a URL to connect properly to my vector store. In my vector store, I have an index, let's say a table of some sorts, and I want to search that index. So I want to take the vector that was created here by the embedding tool. I want to use that to find, in this case, 2 or more similar vectors. The vector field in this index is the text vector field. And the only fields I want to retrieve from my query is a name field, a description field, which contains a description of an image, and then the URL to the image. So here, for example, in this description, there will be, maybe if I have a picture of a cat, well, there will be a description about a cat. And we are going to return that as the result of this node over here. Of course, I want to use the output from that embedding node as input to the vector field because I have to search based on this vector and I want to return 2 results. So from a previous search, I can show you what the result is here. Just like with the embedding, I can go to output and logs and then say, well, what was the input here? These are all the inputs. Well, the input was, of course, the vector I created before in this embedding tool. You see that here. The actual output was, well, 2, let's say, close by vectors that are close to the input vector. So in my case, that's a vector where I can go to the original entity here in my database. Yeah, that's a cat that was returned based on the input that was fierce feline hunter. The second one was indeed, if you look closely here, that was that tiger one. So the nice thing about prompt flow is that you can examine exactly what each node in the flow does, what the inputs are, and what the outputs are. Now, I have this here, that's fine, that's great, but of course, when I do a vector search, I will always have a result. So if I ask for an image that I don't have in my database, I will get some result back from that vector search. And I want to use an LLM to make the final decision about, what I got back from my search here. I want to investigate that further with an LLM so the LLM can select the correct image. So if I ask for fierce feline creature, I don't want that cute cat. I actually want the tiger to be returned. We're going to do that by using an LLM tool. But before we're going to use an LLM tool, I inserted another tool that simplifies the results coming back from AI search. Because AI search results in quite a lot of JSON, and it can be difficult for a model to go inside that JSON and extract the relevant information. GPT-4 can do that, but a simpler model such as GPT-3.5 Turbo might have some issues with going through that more complicated JSON. To simplify the results from AI search, we have this custom Python tool here. Let's go into it. And what you have to do is you have to import the tool object or the tool from prompt flow from this library. And then you decorate a function with a tool decorator. You define the function as having some input, and you can connect the outputs from other nodes to this input. Then you're going to process the input and return an output. So in this case, when I'm using AI search results as an input here or as a parameter, I can then set AI search result to what I want. And the AI search result should be the result from the search in my vector database. What we're going to do here is we're going to simplify it. I just want to go through all the results in this list, right? Because it's a Python list. And I'm going to just create context for the prompt I'm going to send to my LLM, and I'm going to make it simpler. So I'm going to add a couple of lines with the name, which is the name of the original file, the URL of the file, and then a description of the file. And to also ensure that I'm sending less characters than needed to the LLM, so basically I want to save tokens, I'm only going to send or try to send the first 100 characters of the description. The descriptions are generated by GPT-4 Vision, and they can sometimes be quite long. But in the first 100 characters, we typically already have a good indication of what the image is. So we do that, of course, to save tokens, to make the calls to the LLM cheaper. If we look at an example of what happens in this thing, you can see from a previous flow, the input was the AI search results. And that's really a lot of stuff that's in there, right? A lot of data that I don't need. The output here will be just simply these lines here. So the cat JPEG picture and then the tiger JPEG picture. And that means we can now use the output of the search results and we can bring that into an LLM node. So to do an LLM call, we can just do plus and then say LLM. And we get something like this, where we use again our OpenAI connection, the model we want to use, so a chat model, and I want to use a GPT-3.5 Turbo from the more recent ones. And I also want, in this case, to respond in JSON only. I want a JSON return from this LLM call. Now the question is, what kind of prompt are we using here? Well, in this case, I'm using a prompt which is defined in a Jinja template. So inside the Jinja template, you can do something like this. You can set your system prompt and then, for example, use parameters. And these parameters can be the outputs from other nodes in the flow. So I have description and search results. What I'm going to do is I'm going to say, well, the description in this template is going to be my original input description from my input node over here. But the search results are going to be the simplified search results coming from the search results Python node over there. And when we are going to call the LLM with this information, we can see what happens here. So here we see what is the input. The input is indeed the description, in this case for fierce feline hunter, and then the search results will be added to the prompt. The output in this case from the LLM is JSON, because I've asked it to produce JSON with a URL parameter here. Again, if we go back inside the Jinja format, you see it, I indeed say in the system prompt, you return the URL, use the provided context, and return it in this form, the form you see over here. I also had to add some additional data for the model to not make up stuff. So I'm saying never return a URL that's not in the context. In that case, you would return this JSON with the empty URL over there, and don't make anything up, please, right? Try to be nice and get a good result from that. Now it's time to get the result from all the things we did before. So we have the result from the LLM call, and we have some other results like our AI search results. Now what I want to output, so this flow, I want to output three things. I want to output this data field, and we'll get to that data field in a moment, but I also want to output the URL we got back from the LLM. And for my application, I also would like the original search results coming from AI search. So you just define these outputs here, you give them a name, and then like always, you're going to connect outputs from other nodes to your destination node, which in this case is the output. Now, I can show you what the output more or less looks like. When you see it here, you see indeed the output is data. The data field seems to be this kind of data image / JPEG and then the base64 encoding of my image. This is something we can put directly inside an image tag in HTML, or we can just paste this data into a browser bar and we'll get the picture rendered without having to go to the original location. But I also want the original URL that the LLM gave me back, and the output will also contain the list of original search results. So I can display them in my application. As you have seen in the beginning, I can show you what the original search results were. Now, the search results, that's easy. I just connect the result, the output from AI search, to this one here. But to do the conversion to the base64 encoding of my image, and to get the URL, just the URL out, I again write some custom code here. The URL is quite simple. That's just a custom Python node. And here we say, this is my Python code. So I just put in the image JSON result from the LLM. I'm going to convert it to real JSON. I'm going to extract the URL out of it and return the URL. No error checking here, and so we just assume this will all work beautifully. And of course, what we have to do in our flow, we have to then ensure that we indeed connect this properly. Here in this function, we have to make sure that we put in our image JSON parameter to our Python function that should be the output from the LLM call. Yeah, you can see that here. You see the arrow also going to this one. To create the base64 representation of the image, we also need another Python file. In this case, what we're going to do is paste in the image JSON from the LLM. We extract the URL, and then with some helper function, we download the image from its location, and then we convert that to base64 and return that string. If we don't have a URL, then I'm going to return a placeholder that has text no image inside it. And I'm using placeholder.co here to do so. I could have put the base64 representation of such a placeholder directly in the code, would be better because I wouldn't have to do an additional call, but okay, this works. So that means I'm getting that image in base64 and the URL. I'm using some simple Python code to get that to the output. And that's the reason you see all of this in the output node here. You see what happens and what we get back. And that's used by the application you have seen earlier. Here's the application again, so you know now what happens. If I type something like, I want a picture about aliens, we can see that we have a picture return that looks like this. The other image that it got back from the search results is this minion image, and here you see the search results. So aliens JPEG was first, and the second one was the minion image. So you can see that this matches with the output that we got back from the flow. The question, of course, is how do you create such an application? So how do you use a flow within an application like this? Now, this application runs locally. It's made with Streamlit, Python library to create these UIs easily in a browser. And we, of course, also load the flow locally. So what I'm going to show you is how you create a Python application and embed the flow that we created within that application. Of course, what you can also do is you can take your flow and you can deploy this to the cloud by creating a container image from it. You can then put that anywhere. It's an API you can call remotely, and that would be the same thing. But I'm not doing that. So in my application, I will close everything here. If we go to the application that you have seen earlier, that is in the image seeker folder. And here you see that just a simple app.py. I will make it a little bit bigger here. And here's that Streamlit application. And the prompt flow library for Python has a load flow option here. So with load flow, you can load a flow as defined in one of your folders in your application. For example, here we just say that the flow path is, so here is image seeker, right? The flow path is one above. I want to use this flow over here, and more specifically, this flow.dag.yaml. And then the load flow function just takes that path and creates a function called f, in this case, that I can send my description to. So then within Streamlit, I'm just going to use a text input, and I'm going to use this user query. If there is a user query typed, I'm going to just get the flow result by using this code here. So this is as simple as it gets. To call the flow, I just call the f function, and I'm saying, hey, the description, which is the input to the flow, that's the user query we captured from the input box. Now we know that this function has an output with 3 values. There's a data that contains the image in base64 representation. We have the URL to our image, and then we have the search results we can go through to display them in the user interface. What I'm now doing is creating an image tag, and this image tag contains a link tag as well, an A tag, but then an image tag. And the source of the image will not be the link. This is just an example. You could put the link in there as well. The URL could be put in there if the data is publicly accessible. But in this case, we just put the base64 representation of the image directly inside the source attribute. right? Then we only have to use some markdown in Streamlit to show the image tag and also allow unsafe HTML because I'm inserting straight HTML within the markdown of Streamlit. And then the rest is just parsing or going through the search results and showing the information of the other images. So I'm showing the other images from the same source. There's only one other image because I only returned two. And then I display the search results, the JSON you also see on the page. So this code, I think, 38 lines, as you can see in total for a simple application. This is all you need to create this over here. But the real magic, so to speak, is in loading the flow from your folder and then just using that by simply doing a function call within your Python code. Now, there's something quite important I have to mention here. There's nothing here about connections. What kind of connections are used? Well, the connections that are used are the connections that are on my local machine. If I'm thinking of packaging this application up in a container, I can, in my code, override the connections to OpenAI and the connection to my vector database, which is Azure AI Search. And I would then provide, for example, the API keys using environment variables. So on my local machine, I don't have to do that. The connections are reused that are defined here within a prompt flow, as we have seen before. But if I package this up, I will, of course, need to override the connections and provide them, for example, to something like Azure Container Apps that would run this application for me. And with this, we have come to the end of this video. Check out some other resources here. I definitely recommend the first one, which is mainly a guide to prompt flow Visual Studio Code. So you'll find a lot of information there. And of course, Microsoft Learn, which has the basic information about prompt flow that you can use on the Azure portal as part of Azure Machine Learning. Okay, thanks for watching and see you some other time. Bye-bye.